Okay, so the value of g that I gave in the last video on the Earth's surface, we know that the value of g is 9.8 meter per second square, right? And this value of g, is it constant everywhere on the surface of the Earth? If we go on the sea level or if we go to high mountains, does this value of g remain the same? No, it is not the same. In fact, this is maximum. It is maximum where? On the plains. That means on the sea level. Okay, on the sea level, that is maximum, which means that if you go upwards, if you go high into high mountains, the value of g will decrease. It will be lesser than 9.8. And if you imagine that you can dig a hole and you go dig a very deep well, and you go deep into the well, the value of g also will decrease. So in this video, I want to discuss how the value of g, acceleration due to gravity, will decrease, will vary with altitude or height. That means as we go up from the surface of the Earth. All right, so let's say we have the Earth. Okay, r here is the radius of the Earth. Okay, that means from this center to that point, that is the radius. Capital M here is the mass of the Earth, and we have a small body at a height h. Okay, on the surface of the Earth, the value of g is denoted by g itself, and at this height h, it is denoted by g dash. Okay, so on the surface, or on the Earth's surface, on the Earth's surface, g is given by what? G is given by g, mass of the Earth, mass of the body, by distance square. Imagine if this body is right here, then what is the distance of the body from the center of the Earth? That will be equal to the radius of the Earth, so that will be r square. Let's call this equation 1. Then at a height h, above the surface, let us denote that with g dash. This will be what? G m m. Now what is the distance of the body from the center of the Earth? Because always the distance is taken between the centers of the two bodies, is it not? So the distance from the center of this body to the center of the Earth will be r plus h. Okay, so that will be r plus h whole thing square. Let's call this sum equation 2. All right, so we want to find the expression of g dash. So what do we do here? We divide 2 by 1. Okay, so if you divide 2 by 1, so you get g dash by g. This is equal to g m m by, let me write like this. I think you are familiar with this way of writing. Let me write this part first, because since g dash is g m m by r plus h whole thing square into g, so this will go upside down, r square by g m m, right? So I can cancel this part and this part, so I'm getting r square by r plus h whole thing square. Okay, all right, so this implies g dash by g is equal to r square. Now what I can do here, this r plus h whole thing square, I can write it like this. Okay, let me write with yellow. Say r plus h whole thing square. I can take common here. Okay, I can take common here. So let us first take common. If I take common, okay, I can do like this, right? I can write this as r plus h. I'll take a small bracket here, and I'll take a big bracket here, whole thing square. I think I can do that, right? Now we can take common first r from here. So if we take common r here inside the bracket, I will get 1 plus h by r. Okay, I think I discussed with you already. So this whole big bracket will come from outside square. So you're getting two terms here, r and this term in the bracket. So r here, there's a square, so you're getting r square, and 1 plus h by r whole thing square. I already discussed with you this in some of the topics in the previous videos. I don't remember when, but you can take common even if nothing is common out here. All right, so therefore this term here, r plus h whole thing square, I can replace it with this. So that will be r square 1 plus h by r whole thing square. Then cancel r square and r square. So this g from down here, it will go up. So I'm having g dash is equal to g 1 plus h by r whole thing square. Let's call this some equation. What was the last equation number? Equation 2. So this will be equation 3. All right, let's put this inside of a box. We're going to need this later on. Okay. Now this expression, it gives the value of the acceleration due to gravity when the height is comparable to the radius of the earth. Okay, now what we can do here, suppose we can go further. From here we can go further. We can take g dash is equal to this term. Okay, g will be in front out here. This term is to the power 2. Now I can take this term up. So when I take this term up, I get 1 plus h by r. This power now will become minus 2. Yes, because I've taken it up. Okay, and do you agree or not that this h is very, very small compared to the radius of the earth, right? So let me write somewhere here. Since h is very, very small compared to the radius of the earth, so this implies that h by r is very, very small compared to 1. Yes or no? Take this r this side, you get 1 out here. Okay, so in that case, what we can do is we can expand this side by binomial theorem. By binomial theorem, by binomial theorem, 1 plus h by r to the power minus 2, this is approximately equal to 1 minus 2h by r. You remember or not? In binomial theorem, where do I write? Let me write somewhere here. Let me write, okay, let me use a green color. Okay, somewhere here. What does binomial theorem say? The binomial theorem says something like this: 1 plus x to the power n. Okay, this will be nearly equal to 1 plus nx. Okay, this n will go and multiply here. This happens only if x is very, very small compared to 1. Okay, so that is the binomial theorem. So obviously here, if you look at this term, h by r is very, very small compared to 1. Yes or no? So therefore, we can expand this term by using the binomial theorem. And when you expand using the binomial theorem, what happens? This minus 2 will come here in the middle. Okay, so instead of plus 1, in front of h here, there is plus 1. So instead of plus 1, you multiply with minus 2, you get minus 2. So 1 minus 2h by r. I think that is clear. Okay, so what we can do, we can replace this with this term. So therefore g dash is equal to g times 1 minus 2h by r. Okay, this is our required expression. Okay, let's call this equation. Sorry, what equation is this? Equation 3, so that will be equation 4. Okay, Right, so now let us interpret this equation 4. Okay, now the interpretation part is important. All right, so here this term, this sign in front of g out here is positive, which means that this term here is positive, which means that this term 2h by r is very, very small compared to 1, right? So as h increase, what happened to this term inside of the bracket? Okay, what happened to this term inside of the bracket? It becomes lesser and lesser than 1. Yes or no? Lesser and lesser than 1. So if this term decreases, then if you multiply it with g also, this entire term on the right hand side will decrease. Are you getting the idea or not? Let me explain to you nicely. So here, this is the explanation part. Okay, the physical interpretation. Okay, so if you look at this equation 4, as h increase, what happened to this term 2h by r? That will increase. Yes, so if we take 1 minus 2h by r, what will happen? That will be decreasing. It will be lesser and lesser than 1. Okay, and if you multiply this value, which is lesser than 1, with g, that means this entire thing will decrease. So it means that as h increase, the entire thing on the right hand side will decrease. So that means g dash will decrease. As h increase, g dash decreases. Okay, which means that as you go higher and higher up from the surface of the earth, all right, the acceleration due to gravity decreases. Okay, and if you plot a graph, how would the graph look like? Say you're plotting g dash along the y-axis, and you're plotting the height along the x-axis. All right, so of course when height is 0, then that means height is 0 means what? It means that it is on the surface. Let me look at that diagram once again. Where is the diagram? Here. Okay, if height is 0, it means that this body is where? On the surface, right? And on the surface, what is the value of g? It is denoted by g only, 9.8, which is maximum. Okay, let's go back here. So therefore, when height is 0, that means at this point it is maximum, which is equal to g. And then as h increases, as you go towards the right side, what happened to g? G will decrease. Okay, how does it decrease? It decreases like this. Okay, so g becomes 0 if h is very, very large, if h is infinite. Got the idea? So this is how the value of g varies with height or altitude. Okay, just as an example, what will be the value of g at a height equal to the radius of the earth? Okay, if h is equal to r. All right, so therefore g dash will be what? Will be g 1 minus 2. Instead of h you write r. This will be r. Wait. 1 minus 2. Okay. Yeah, we cannot use this one. That is one thing that I want to tell. Okay, we cannot use this expression. All right, so in fact, let me give you one special case or important point. Okay, let's take an important point. Now this point is going to be important when you do numerical problems. Now the first point here, if suppose if suppose h is comparable, no, let's not use that. If h is comparable to r, to the radius of the earth, then which equation? This equation, I don't remember what equation. Let me have a look. Let's see this one. yeah, that one, equation 3 is used. Okay, then equation 3 is used in numericals, just like the numerical that I gave you just now. H is equal to R, so obviously H is very large and it is comparable to R, so that is why we cannot use this one. Okay, what is the condition that you can use this? Only if H is very small compared to R. So let me write down that condition B. If H is very small compared to R, then equation, is it equation 4? Yeah, then equation 4 is used. Okay, so therefore what is wrong with this example here? We cannot use this one. All right, so let us use one. Let us use g dash is equal to g 1 plus h by r. Okay, so here you will get what? G 1 plus h is equal to r, so that will be r by r, r by r, r by r, this will cancel. So you have this is equal to g by 1 plus 1, which is g by 2. Okay, and g by 2 is how much? Oh, there's a square out here, I forgot. There's a square here, so there's a square here, so that'll be 2 square. So you get g by 4. Okay, what about, let us take another example. Let's take example 2. Example 2, what is the value of g at a height of let's say how much shall we take? Let us take 640 meter. Okay, 640 meter. Obviously this height 640 meter is quite small, compared to r. No, you know what the value of r is? R is 6400 kilometer, right? What is the value of r? 6400 kilometer, and if you convert this to meter, you will get 6.4 into 10 to the power 6 meter. Okay, so here let us first write the value of h in kilometers. So this will be 0.64 kilometer. So now which formula do you use? G dash is equal to g 1 minus 2h by r. Okay, so you put here g and 1 minus 2. Just put a value of h here as 0.64 and put a value of r as 6400. All right, so what will happen here? So you can just find here, put a value of g as 9.8 and then you find this term inside of the bracket. Okay, you will see that the value of g dash will be lesser than 9.8. Okay, please do this and complete it by yourself.